Good morning, everybody. If you're listening to this, that means I am not in class, but this is the lesson that you would get if I was there. So it almost is like I'm there right now. So today we're going to solve log equations. And over the next 2 days, this is actually a 2-day lesson. We're going to solve log equations where log can be on both sides of the equation and where logs may just be on a single side. Today, we're just going to focus with logs on one side of the equation. So here are the steps. I've already written them. First, if necessary, you're going to condense to a single log on each side of the equation. You might have to do this, you may not, but we'll get to examples where you don't and where you do. If you condense logs on both sides and it turns out that you have log of something equals log of something, simply cancel out the logs and then set the something equal to the something. No more logs. However, if you come up with an equation where there's just a log on one side of the equation, this looks like last night's homework because it is last night's homework. You simply translate it, the base raised to the exponent equals the result, and then you solve. Now, step 4, notice how I hand wrote that in there. This may be the most important step, however. Check for negative or zero answers or solutions. So what does this mean? Well, let me zoom out. Now, you know what I'm going to do? I'm going to draw an arrow right here, and I'm going to keep going and scroll all the way up to the top. Okay, what if I asked us to solve this equation? Log base 2 of negative 4. First off, you might say that's not an equation. Well, set it equal to x, then translate it. 2 raised to the x power equals negative 4. So, what exponent can I raise 2 to make it equal negative 4? Well, 2 squared equals positive 4. Ah, Mr. Clody, I know. Let's raise it to the negative second power. Let's try it. 2 to the negative second power. Wait a second. 2 to the negative second power doesn't equal negative 4. It equals 1 over 4. Yeah, so that doesn't work. As a matter of fact, there is nothing that you can raise 2 to make it, no exponent you can raise the number 2 to make it equal a negative answer. So the answer to this question is there is no answer. That's the answer, that there is no answer. Same thing if I say 2 to the x power equals 0. There's nothing that I can raise. There's no exponent I could raise this to make the answer be 0. So, ladies and gentlemen, we're learning something right now. I could never get 0 as a result or negative number as a result. So you cannot take the log of a negative number or 0. Now, what do I mean when I say that? Go back up and let's look where this answer came from. This answer of negative 4 it's the log of negative 4. So I can't take the log of a negative 4 is what I'm trying to say. Okay, you cannot take the log of a negative 4. I cannot take the log of 0. All right, ladies and gentlemen, let's just start solving equations here. Okay, so log base 2, and I'm going to zoom in on this now, give myself a little bit more room to write. Okay, I'm going to answer just these first 4 questions, and that's it. Call it a day after that. I'm going to use blue or purple. I haven't used purple. So first thing, I'm going to translate this. It's this base raised to this exponent equals this result. Get used to that. For those of you who are still, if I ask you to translate, you're still going, practice this. No one should be saying, you should be saying, Mr. Colodi, 2 to the third power equals x minus 4. And you should be done with it. That's how quickly the translation should go. If it's not that quick, you need to practice more. 2 cubed is 8. 8 equals x minus 4. Add 4 to both sides. X equals 12 is my potential result. So then I'm going to do my checks in red. Okay, I'm going to do my check in red. If I plug in 12, I get log base 2 of 12 minus 4. All I'm really doing, everybody, is just checking to make sure it's positive. Is 8 a positive number? Yes, it is. 8 is a positive number. It checks out, so that checks. That's it. I cannot take the log of a negative number or 0. That's it. Honestly, as long as you do the correct algebra, as long as what you're taking the log of is positive, you're good to go. That's all I'm looking for in a chapter. Let's do number 2. Again, what's the translation? There's not a single person that should go, it's 3 raised to the second power equals result, x squared minus 8x. So now that I'm here, 3 squared is 9. That equals x squared minus 8x. But wait a minute, I have an x squared and an x. This is a quadratic equation. How do I solve a quadratic equation? I bring all the terms to one side. So let me rewrite that over here then. So 0 equals x squared minus 8x minus 9. Now I need to factor this thing, this puppy. And what multiplies to give me 9? Negative 9. And adds to give me negative 8. How about negative 9 and positive 1? Negative 9 times 1 equals negative 9. Negative 9 plus 1 gives me negative 8. But what are my two solutions? They are x equals 9 and x equals negative 1. I should say these are my two potential solutions. Now I need to do my check in red. My check. Okay, so the first check, I'm going to do the log base 3. I'll plug in 9. So that's 9 squared minus 8 times 9. That's 81 minus 72. Yeah, that's the log base 3 of 9. That's positive. That checks out. So then how about the other one? What if I plug in the log base 3 of negative 1? Ooh, negative 1. That's going to be scary. Negative 1 squared minus 8 times negative 1. So then negative 1 squared is 1. Negative 8 times negative 1 is positive 8. Ooh, and 1 plus 8 is 9. Log base 3 of 9. Once again, that checks out. So you know what? Both of these answers check out. That's it. I'm just looking to see that I have the log of a positive number. I am not allowed to have a log of a negative number or a log of 0. That's it for example 2. Okay, let's go to example 3 now. I'm just doing 4 examples. Example 3, example 4, and then I'm done. Uh-oh, this now has 2 logs on the left side of the equation. So go back to step 1. Condense to a single log on each side of the equation. So that's exactly what I'm going to do here. Because of this plus sign, let me go back to my purple color. Because of this plus sign, I'm going to multiply. So this becomes the log base 2. I'm going to take the 5 and the x minus 2 and multiply them. So it's going to be 5 times x plus 2. And that equals 4. So this is the log base 2 of 5x plus 10 equals 4. Time to translate. No one should be saying, no, it's 2 raised to the 4th power equals 5x plus 10. Boom, translated it. All right, use your power chart if you need to, or just use your fingers. 2, 4, 8, 16. 2 to the 4th power is 16 equals 5x plus 10. I shall subtract 10 from both sides and get 5x equals 6. I'm going to divide by 5, and I will get my potential solution, x equals 6/5. I need to check my work, or when I check my work, I need to check my solution. All right, so the only thing I need to check, plug it into in red is the log base 2 of x plus 2. So I'll check right here, log base 2 of 6/5 plus 2. 6/5 is 1 1/5. 1 1/5 plus 2 is going to be 3 1/5. Is that a positive number? That's all I care about. That's a positive number. If it's a positive solution, that means that 6/5 is a solution to the problem. Bam, done, done, and done. And I have one more problem that I am going to do with you. It is number 4. Once again, there's a plus sign in between. So when I condense, I multiply. So this becomes the log base 6 of x times x plus 1. And then that equals 1. So this becomes the log base 6 of x squared plus x. That equals 1. All right, ladies and gentlemen, translate time. 6 to the 1st power equals x squared plus x. I'll be honest, instead of writing it again, isn't 6 to the first power just 6? Yes, I'm going to subtract 6 from both sides. And I will get, I'll write it up here. Let me write it over here. Let me slide over to the right so I have room to write. All right, so I will have 0 equals x squared. I'm going to write plus 1x minus 6. Then I'm going to write my parentheses and do x and x. What multiplies to negative 6 but adds the positive 1? How about positive 3 and negative 2? 3 times negative 2 is negative 6. 3 minus 2 is 1. Do my sticks, and I get x equals negative 3, and I get x equals positive 2. Here are my two potential solutions. I'm going to get my red pen out one more time, do my check here. But I got two things I got to plug into here. I got to plug into x plus 1 and x. So let me start with the 2, because this seems less scary here. I'm just going to extend this and do the check when red. Okay, let me kind of do this just like that. Let's do my check. If I plug in 2, this becomes log base 6 of 2 plus 1, which of course is 3. That checks out. And then log base 6 of 3. That checks out. That's so log of positive numbers. So 2 checks out. I'm a little concerned about negative 3 here. So this is log base 6 of negative 3 plus 1. Ooh, that's going to give me, I'll stop right there. That's the log base 6 of negative 2. And then if I continue, this is also going to be the log base 6 of negative 3. Can I have that? No, I have a log base 6 of negative 3. I have two negatives right there. So that means that negative 3 is not a solution to this problem because it produced a log of a negative number. I cannot have that log of a negative number. I'm going to zoom out now. I've done examples 1, 2, 3, and 4. Now, in order to get credit for class today, in order to let me know that you were in class today, you need to do one problem on ClassKick. One problem and one problem only. I'm going to turn on my video. There I am. Hi. Hey, here I am. You're going to do one problem on ClassKick, and let me pull it up right now. Here it is. You're going to go log on to ClassKick right now. You are going to do this one problem. You are going to condense the logs on the left side, and there's a plus sign. So what are you going to do? You're going to multiply. Then you're going to translate and solve and check for any extraneous solutions. Check for any negative or 0 solutions, just like we did in those 4 questions. That's it, everybody. That's all I got to say. And do this and have a great class and a great day. Bye, everybody.